Hi, welcome to Minds Behind Maps. I'm Maxim Lenneman, and this is the latest episode in this experiment where I want to sit down with people who are creating and using anything geospatial to try to understand more about the field and the people in it. My guest today is Tyler Erickson, who is currently a developer advocate at Google and works more specifically on Google Earth Engine. We touch on what being a developer advocate means, as well as go behind the scenes on what Google Earth Engine is. To bring in a bit more context, and using Google's own words, Earth Engine is a cloud-based geospatial analysis platform that enables users to visualize and analyze satellite images of our planet. In my own words, it's mostly becoming the go-to platform that I'm seeing more and more people who are entering the world of Earth observation go towards. The idea is quite simple. Google does all the data engineering, building all the pipes required to move data around and assemble different datasets together to provide a coherent assembly of data for users to work on. Google handles the complexity of merging different sensors and datasets together, and users focus on combining all of them to make a map of visualization and just overall solve their own problem, focusing on the problem itself. I was quite excited to chat with Tyler to learn more about the behind the scenes of this project that's been going on for many years and is growing even more popular in the world of remote sensing. I have to say, I've been a bit skeptical at the growing importance the platform is taking, mostly as in a world of open source, working on a text giant platform where one doesn't own the data nor the compute is something I've always tried to keep a skeptical eye on. That being said, I also want to be able to understand what these projects have to offer in more depth and understand more on how they're being built and the philosophy behind them. I've used Google Earth Engine for a few projects in the past, and I think it's a great tool for many applications. I also believe we should ask questions with regard to the ownership and dependencies that we're creating in this process. We don't simply talk about Google Earth Engine, we also talk on some of Tyler's earlier career and how innovation and new ideas can come out of being curious about different fields that at first glance might seem unrelated to one's interest. I've been thinking a lot recently on how innovation happens and how bringing ideas from different fields can help on that. We also, of course, talk about some of the behind the scenes of how Google Earth Engine came to be, from philosophical designs to more technical ones. Finally, I also want to take more time to go through an application Tyler has worked on that does leverage Earth Engine to understand how it can be used and is used to build real-world solutions. As always, feel free to reach out to me on Twitter. I'm at Max Lenneman, or follow the news related to the podcast at Minds Behind Maps. Links in the show notes. On a quick side note, this marks the first episode of 2022. I hope to bring you many more conversations throughout the year to come, and thank you very much for being here and listening. I hope you enjoy our chat and have a great new year. In the meantime, here's my conversation with Tyler Erickson. Hi, Tyler. Welcome to the podcast. Thanks a lot for doing this. If you've listened to this, you know that I always like starting this with the same question. So I'd like to ask that same question again. I'd like to ask if you could describe yourself, or how would you describe yourself?
Sure. Well, first, thanks for inviting me on. I've actually been listening to your podcast for a while. I know it hasn't been going on for all that long, but been listening to and it takes a while to get through them because I definitely like the long form format. So let's see, how would I describe myself? I'm going to describe myself in terms of categories, I guess, okay. Realizing that it's not always the best way, but it can be a good way to convey if somebody has a shared experience, very quickly, what I've been up to. And one of those is that in some sense, I view myself as an engineer. That's my educational background, civil environmental engineer along the way. And I kind of approach a lot of problems with that mindset. We have a bunch of resources, we have a bunch of laws, we're trying to optimize something. Right. So, and I think usually when I'm describing myself to, it depends on whom I'm describing myself to, trying to figure out what the most effective way is to. I am also, I wouldn't say a maps person. I don't normally describe myself that way unless they know nothing about geospatial, but if they do, right, then I'm not a cartographer. I mean, I was chuckling when you interviewed, I think, Joe.
Yeah.
He's like, I'm not a maps guy. Yeah, I've never taken a cartography course in my life. I'm not a GIS guy. I do a lot of geospatial programming, but GIS is not something I like. But I am a geographer, at least by training. That's my PhD is in geography. It happened more because the advisor that I wanted to work with was in the geography department, and he was actually a chemist. But geography is kind of a catch-all for many things spatial. So in some universities, that's where the programs are. I was doing hydrology at the time, but I ended up being a geography PhD. What else would I describe myself as? Earth scientist. That's the community I normally work with, folks that are dealing with something about processes on the Earth's surface. My background's in water resources, hydrology, a snow hydrologist, actually, if you go deep into my background. But that's a lot of, I think my current work is just working with other earth scientists and understanding what they're trying to do. If I'm working with somebody that's, a earth scientist, then I probably would describe myself as a technologist, because I can talk their language. I've been there in terms of doing field work and have that experience, but usually what they might find interesting is the informatics work that I've done in the past, geospatial work. So I guess I'm a technologist when I'm in an earth science place. If I'm, where I work right now at a technology company, I'm an earth scientist, because that's the distinguishing characteristic of it. So I think those are my categories, I would say. And as I said, I think those can be useful for like starting a conversation, but categories often are stereotypes of something. And so they can be both useful, and they can also be stereotype is kind of the negative connotation often of a category. And I think about that a lot in terms of like, these are models that might be useful and might not be useful, whether you're describing people or you're describing a process that's happening on the Earth's surface. And when people get too sucked into a particular type of model, it can be good to start off, but it might be damaging in the long run. And so I guess, and I can't remember which of your previous speakers it was, they talked about, hey, it's more of the characteristics of the skills. And that, to me, those are more of the non-categorical continuous variables that give a closer picture of what a person is, what they do. So it's often useful to, I think, go into that. So I would say I'm super curious. I just love learning. I was described for a while as a serial grad student, that I would go get a degree and then go off and do something else and then come back and get a degree, and ended up accumulating a bunch of graduate degrees because it was just, following what I thought was interesting at the time. It was not to go out and stay in academia, although I did stay in academia for a while after getting my PhD, but it was following what I was curious about, because I love learning. And even when I was doing a degree, trying to focus on something, there was all these, like, I don't know if they're distractions, but other things that I was curious about that I learned along the way. And I think that actually has helped me in the long run, although it's, it's frustrating probably to the advisors I had at the time.
Yeah,
that's like, hey, you got to focus.
This is actually, let's go there, because I just finished reading a book that I really recommend. It's called Range. I don't know if you've heard about that one, from David Epstein. And it really is like valuing that. Exactly. It was like trying a bunch of different things, and it's kind of making a stance against focus, what we usually describe as focus, which is exactly what you were mentioning here, where you have professors that are like, no, you need to specialize in this thing, or really focus. And this book really takes a stand against that, and says there's a lot of value in trying a lot of different things and being able to aggregate all of that and become more of a generalist rather than a specialist. And he takes a lot of different examples about cases where bringing different people that might have completely different skills to work on the same problem usually yields innovation and different ways of thinking, rather than people who's really specialized in that and might have just taken or heard from other topics from people who already are in the field. They're not really thinking of something new. So Yeah, has that actually been the case for you?
I think so, and it definitely is like some of the most interesting things I've learned along the way weren't taught to me by somebody that was in the same field, I
Right.
guess. If I think of a few examples about that, I was studying snow as my PhD, and one of the interesting things about snow is that the properties keep changing. So snow falls, it might turn into some solid, super solid, dense ice sheet of a glacier, or it might turn into some dangerous slab that avalanches happen. And it totally depends on the process that the snowflakes go under. And one of the most interesting talks I ever heard on that didn't come from anybody in the snow community. It was somebody that did material science, and they were trying to make things harder. And there's a process that's called annealing. And depending on how you apply temperature, the rates, and to a metal, you can make it change the properties. You can make it quite a bit stronger. Um, and he came and he talked to at a snow conference because he got invited, and to me that was like totally interesting, because it did describe what you actually see snow grains going through. If you think of the physics of it, there's many similarities, many differences to it as well. And then another thing I went to study was, actually this is before the snow, but it was geostatistics, spatial statistics. And one of the techniques there for simulating realizations, equally likely realizations that you can build your statistics from, is called simulated annealing. And they take that physical process and they try to simulate that with a computer. You move, tweak things, and they have certain rules. And if you do it in a certain way, you'll come up with a realization that might inform you more about the process that you're trying to simulate. And like geostatistics, when I was studying that, I was studying groundwater. So it's a place that is so sparse that you don't have much in the way of data. You're trying to study what's underground. Putting a well in to actually pull out physical properties or do a pump test of like seeing how water flows is horrendously expensive. So it's a technique that the techniques are different depending on which field you're in, but they can cross over and be very useful for something else. Like
Right.
annealing is just one example, but I've come across that quite a bit, and I often will go and try to learn something with thinking that, hey, it might be useful later on, but I have no idea how. But it sounds really interesting. So let's get a little bit, expand my conceptual model of like the way the world works, and maybe it will connect later on. And maybe it won't. But if you do that enough, and you do it in a way where you're making risks in a good way, all of a sudden things will connect later on. And I was doing a PhD in snow hydrology with somebody that had no background in statistics, but he knew a lot about snow. He dug a lot of snow pits, so we could connect on that, and I could bring over techniques that I learned for working with sparse data on groundwater,
Right.
more sophisticated mathematical techniques, and apply them to snow and see where that goes.
Yeah, I was going to ask, how do you think you can um, turn that into a sort of process to because it does sound like, if we take the story you just told where it's someone from material science who goes to a snow conference, it doesn't feel like there's a process where it's like, if you're in snow you should look out for material scientists. It's really like getting completely outside of that field and finding that bridge that is actually pretty hard to find. And if you're not one foot in both of those fields, you actually don't have a way to be able to see that. So is that for you, like, curiosity is just that driver that allows to maybe hopefully like find those, stumble across those things that might be helpful? Or do you think that there might be something else that helps us solve a lot of those problems? Because I feel like a lot of really interesting problems get solved like that when people bridge bringing these different things together, but that process seems very complicated.
Yeah, it's very stochastic, I guess. I would say sometimes it works,
Yes.
sometimes it doesn't. I find, well, actually, one of the conferences that I've been going to, starting as a student, but throughout my academic and professional career trajectory, is something called AGU, American Geophysical Union. It's the largest earth science conference. Currently, I think it's around 25,000, although with COVID, it's probably going to be smaller this year. They're trying to do it in person. But it's kind of amazing. You go there and that's like where the earth scientists, there's planetary scientists as well, and those are kind of interesting to go and watch their talks or their posters. But you can just walk around for a week, and if you get energized about new ideas and things you didn't know about, it's great. And usually what I will do is, there's certain communities that I will want to reconnect with, and I'll go to those. But then you get overwhelmed, with that adrenaline of talking to somebody for like 10 hours at a time. And so if you want to kind of tune out for a little bit, you just go walk down the, planetary science aisle and look at their posters and talk to somebody and just drum up conversations. Yeah, I guess that would be one of my skills too. Is just like, if you put me in an environment like that with earth scientists, I can usually talk to somebody and find a person that is a connection in between us quite often.
Right.
Just because I like doing that, and I've been at those large conferences for about 20 years, so making those connections, and that's often how I even find folks now, I guess, that work on the products. It's just like, hey, I'll just look through the thousands of abstracts and see if something looks interesting, and then try to find 10% of them when you're at the conferences.
Okay, wow, that
just
sounds
walk
like
around.
Really time-consuming effort, but I think if you find those people, it's probably really worth it.
Sometimes, and sometimes there's no connection, but it's always, and it's not always just a scientific connection too. It's kind of a culture. I'm always looking for somebody that is collaborative, open to. I don't want to say open to new ideas, but they view collaboration and sharing as one of the drivers of their success. And you find that in some people and find that in others. I mean, we can talk about the incentive structure in academia, and it's kind of a little bit warped. I think.
Yeah.
But there are people there that truly value collaboration over personal advancement, and I think they are the ones that actually will advance the field more than the ones that are into personal advancement.
Yeah. I mean, we can go over that academia. The thing is, like, I'm very wary that, like, I actually don't know that much about it, and so a lot of what I know from it is reported from people. I spent a very short time in a academic environment and try to get out, because I saw that quite a bit, like that it felt very, in my experience, like there's a lot of great stuff that come from it, but it didn't foster that let's bring in new ideas. And so I think for me that made me go away from it. And the I don't know if the industry is like it's the word that gets thrown around, and I think sometimes it lacks that collaboration as well, so it might have not been necessarily a great bet like that. But I think it's really interesting outside of academia in like the industry to see how people try to do that. And there's incentives there that are also really tricky. Like, I find this idea of exploring ideas sometimes really hard to find in the industry, because there's this idea of return on investment, that the thing that you do, it should yield something at the end, and we're very resistant sometimes to try out new ideas, to seek out new ideas in hopes that they might yield something new down the line. And then I'm it's just something that I've been thinking a lot about recently, is how do we put that investment in, because I really do see it like that, as an investment where you have to try out a bunch of stuff, and as you said, sometimes nothing happens, but sometimes something does happen as well. So have you seen that happen also, now that I think you're a little bit outside of academia? Have you seen that process try to happen as well a little bit, where you still try out new ideas with new people and things like that, and potentially they just don't lead anywhere?
Yeah, I think that whether you're in academia or not, that can be the case. I guess we're in my current role right now. Yeah, there are, you do little explorations of collaborations and partnerships, and sometimes you find all the pieces together. I think actually, regardless, you're always looking for whether there's a common end goal that interests and both people value.
Yeah.
And if there's a path to get there, and you don't necessarily know that from the first conversation. And if you have worked with somebody multiple times, you might be able to trust that that's okay, because you know the characteristics of that person. But yeah, whether in academia or not, I think there is some type of calculation that you have of how much risk you can take. And the parts of academia that I always found a bit frustrating is that you're what is the saying? You stand on the shoulder of giants. You're building on what has come before. But the incentive structure for you got to publish in a journal and get cited, and you are evaluated by how many publications you put out, doesn't really tend to make people want to share so that others can build upon their work, because you get funding if you can convince somebody that you are the best researcher for the proposed research that you're doing. And if suddenly there's 10 of them because you shared everything, that can be a disincentive. So it's only if you can move fast enough and the people that you share with are also sharing, allows you as a group to move faster, then you can, I think, capture that funding stream. But if some people just in academia focus very narrowly on something, and they don't want somebody else to be able to do the same thing until they're at the end of their career.
Do you think there's a way where we can change? I mean, I think this, topic has been explored a lot, but I'm very curious to ask people, like, we've gone a little bit through that. But do you think there's a way in which those incentives can be changed a little bit to try to foster that? Also, because like the way people collaborate today has changed a lot just in the past decades. Like the way people communicate, the way people work together has changed a lot. Do you think that there's a way to change a little bit those incentives to go towards sharing a lot more, to like incentivize that being a thing?
I think you can lower the barriers to sharing, make it easier. That would have been something that I think I would have benefited tremendously from when I was in academia. And to put that sort of in our terms of technologists, it's just like version control is not something that they teach, to somebody in earth science. Like if you're writing, you write software, it's not computer science, formal, but you're scrappy, learning as you go, researcher, writing software. Version control is still so valuable. It's like, if I wish I could look back a year into my past and try to collaborate with myself, because I used version control when I was a grad student. But, unless that's taught, that skill, it's hard. You don't learn the value of it until you've used it for a while. And so I often will work with researchers and, hey, share your code with me. And then you get a copy of folders that is final and final version 2 and final. It's really hard. And so sometimes you have to step back. It's just like, okay, have you heard of software carpentry? They have these great courses that just teach you about Git and version control. It's such an investment. Go do it.
Yeah.
It's good. So part of it is, just lowering the barriers. Sometimes it's just by education, just making people aware of things that they're not aware of that are out there. They just don't know why it's relevant. So that's one way. Another way, I think, is there is both carrots and sticks, I guess, in terms of collaboration. You always want to be, I don't know if is that the saying that you have over there?
Yeah, I did incentivizing rather than punishing, I guess, is
yeah. I could say both are sort of valuable, and sometimes whatever one thing that might be proposed might be viewed from one side as a carrot and a stick, but just the sheer funding that you get in order to work on something, can there be more strings attached to part of this work has to be towards making your work somebody can come along and build on it, replicate on it. And let's see, I was at one conference it's a hydrology conference, and this is a group, Kawazi, that actually is really good at sharing. I'm not sure whether it's because they have different funding sources, but the people in there tend to be very good at sharing their code and things like that, the hydrologists. There is a researcher, James Call, and he was up there at the presentation and showing how his work, how he's sharing it at the end, puts it on GitHub and stuff. And then he had this comment. He's just like, I'm not done until somebody can actually do what I did in 5 minutes, get to the point that I put out a paper and can replicate it in 5 minutes. And I'm being a little careful with that word. Reproduce and replicate to me are similar, but they're kind of distinct too, like which one is important. Academics, you often hear them saying that they want reproducibility. There's a crisis, something gets published and somebody else can't reproduce it. And I think that's true. But I think in a cloud era where we have such a massive amount of data, strict reproducibility isn't really the gold standard. It's like, can somebody actually take your method and replicate it on a new set of data? Because the original data that was there, maybe you were working with Landsat collection 1, or even before they got to collection 1, it was processed in a variety of different ways over time, thousands of different files. If they came out with Landsat collection 2, which they have, do you expect to get strictly the same answer? And I would say, no, don't worry about it if you don't. You don't want the conclusions to change, but strict reproducibility to me is it's interesting, and I view that as valuable. But if you can replicate a result with new, better calibrated data, or for another part of the world, that to me is more valuable. So how can you,
I think we're in a field where there's a lot of potential through things like GitHub, like everything that touches computer science, I think has this huge potential of the ability to reproduce the code. And I do hope that becomes a requirement down the line, that if something, it's not just putting a paper out there, but it's also putting a lot of the tools that you've developed to do that. I've actually been really surprised entering this whole field and just coming into computer science in general and everything that touches it, to see how open a lot of the things are. Granted, sometimes they're preprints, but in machine learning, for example, a lot of stuff is just open and you can just take it. And I think it's a great standard. Like, more and more stuff, people are like, that paper is cool, where's the code, how can I use it? And I think pushing for that, it's been, honestly, I've been very pleasantly surprised to see that push coming from people that are like, yeah, we want that, compared to other fields. I say that all the time. I come from mechanical engineering. That's not the case. Like, papers are not always open, and it's like, before you can replicate that, you need the hardware, you need all that stuff. In a world where we can run the code, and granted the data might change, I think it's amazing that we're moving towards that. I hope that really keeps going in that direction. That's, I think, how it also becomes accessible. And to what we were saying earlier, that's how people, I think, from a different field can, if it's easily available in 5 minutes, you can reuse it. Then the barrier to just tinkering with stuff and trying it out, I don't know, if you're working on snow hydrology and someone in material science puts their code out there, you see it at the conference and you can try it out. I think that would be amazing. And I hope it makes me happy to see that a lot of the research is going towards that direction. It's still not completely there, but I'm glad to see it is moving towards that direction.
I think it varies depending on which scientific domain you're working on. Like the machine learning, I would agree that they have a culture of openness. If somebody can't actually try out and rerun what you've done, they probably aren't gonna reference it. They're gonna. It's such a fast-moving, popular field that I think being open is an advantage there. But there are other smaller fields that aren't as fast-moving, like in the earth sciences, and you have a lot of the old guard that from 20, 30 years ago still actively doing the research.
Right.
they don't quite have that same culture. So I do agree that it's shifting, and there's been a lot of positive work that different organizations have done in this area to make research research communities act more in a sharing way. But it varies dramatically, I would say.
With that, let's move on to what you're currently doing today. I think if I got this right, your official title is developer advocate for Google Earth Engine.
Yep.
I've actually been curious as to what that means, because I, to be very frank, I actually am not quite sure what that means. So I'd be very curious to know from you what that actually means and represents.
Yeah, so developer advocate, kind of, I think it's literally what it says. There are developers out there. I guess the definition of developer could be broad, like some of them are programmers, many of them are, but there's often products that have developers that are not necessarily programmers. They're using it in a different way. There might be some GUI interface or something like that. But there is a group that can make use of a product, and there are folks inside the technology companies that are advocates for those group of people. And I often think of like what my job is usually is understanding what they're trying to do, understanding the path that they're taking to try to get their work done and the barriers that they encounter, and figuring out how to get them over, around, or hopefully get rid of the barrier. And it changes all the, like the barriers 5 years ago are not the same barriers that we have right now. And so it does evolve quite a bit. And yeah, I guess that's the biggest summary. And there's a lot of activities that go around with that. Part of it is just education. It's just like showing what are the current capabilities and the pros and cons that we have with the current system right now. So that is writing good documentation, not necessarily more documentation, but the right documentation that they're looking for. So it's actually truly useful. Hosting events. We've had a series. We have an annual conference right now called Geo for Good. It's actually going to come up in the next month. And up to about 3 years ago, we had a Earth Engine user summit, and then we merged the two because there's such an overlap in terms of the participants that it didn't make sense to keep them separate. So, putting together events like that, whether it's something that we're hosting, bringing together people from over the world, around the world, to get together and share their experiences, learn. Sometimes it's going out to other events like AGU that I mentioned is the big one here in the United States. There's an equivalent EGU, European Geospatial Union, that goes on in Vienna each year. There's more technology-specific conferences that, like for remote sensing. IGAR's Living Planet Symposium is one that's coming up next year. That's going to be great. So going to those events, just talking with folks, having a booth, participating in sessions, starting to form collaborations to the point that you're actually publishing research and guiding individual groups. Can't do that too often because it's very time intensive. So I have to be selective about who I do that with. And then, so that's a lot of the outreach, the sharing what the product can do, how it could be beneficial, or how it might not be beneficial for what you're trying to do. The other part is, the other direction is like coming back and letting the software engineer teams know, are you in the right direction? Okay, you're planning out your next year on features. How should the product evolve? And Earth Engine has been a great product in terms of, I think, incorporating the community that we are trying to serve into the process. We started off by gathering together folks that were interested in forestry. This is about 10 years ago now, and kind of saying, okay, what are the biggest barriers that you are facing? And then we look at what assets we had available to Google at the time. And sometimes, we don't have to build it. Sometimes it's there. Sometimes, it's out there, but we don't have to build it either because somebody else did. That's great too. Earth Engine itself came out of, there's an early group called Earth Outreach that is support for nonprofit public benefit organizations that might benefit from geospatial tools. And that trying to think of what year that was. It was around 2006, 7. I think that it started
Okay.
off. Rebecca Moore discovered or put Google Earth to a good use of encroachment that a logging company was trying to have a timber permit for her neighborhood in the mountains above Silicon Valley, Santa Cruz Mountains. And so Google Earth was kind of newly released at the time, and she used it to great advantage to like tell a story that people could relate to. And that lit kind of an idea among many nonprofits. It's like, hey, we've got a really important story to tell about the environment. Here's a tool that could do it. And it, it's evolved from there. It's gotten to be a better environmental storytelling tool over the years, but that was sort of the genesis of Earth Outreach. I guess that evolved for a while. Is presentations on Google Earth and what it could do to different conservation groups. At one point, there's a meeting of conservationists down in South America that were looking at the Brazilian Amazon. And during a presentation that was down there showing Google Earth, there's a bunch of scientists that were in the audience that came up and said, that's great, we can see it, but there's so much valuable data that you are just displaying as a base map, like a background. We want access to that. And that was right about the time that USGS and NASA said, hey, we're going to make Landsat free and open. So there was this availability of satellite imagery from 40 years. And there were these conservation groups that said, hey, we want access to the raw imagery for analysis. Right. And so that's how Earth Engine itself started. I think that's about, 2008 is when Landsat announced that they were making their archive free and open.
Okay.
And I think it didn't roll out until the next year is when they actually got their data system in place to do that.
Right.
And then Earth Engine was about a year after that.
Okay, so that's where also, because back then I didn't really know what all of this was. Trying to put the pieces together. What happens there? Does Earth Engine start ingesting all the Landsat data? Kind of as we know Google Earth Engine today, where you can go there and there's multiple data sets. Did it start off like that, or was it trying to take a different approach?
It started off with Landsat, at least, because that was what the forest community was really interested in.
Okay.
As a base large data set. I mean, there's obviously many other data sets that you have to have in terms to make it useful, like political boundaries, watersheds. But those were added over time. And those data sets, there were tools to work with that volume of data before, like watershed boundaries and things like that. But there weren't really good tools to deal with something like the Landsat archive. That is, each scene is 500 to 750 megs. Like it's probably even larger now that we have higher signal noise. But they're massive. They fill up a hard drive in just a couple of scenes.
Yeah, especially I think in 2008. It's probably not the same hard drives as today.
Yeah, so that was, there was a gap basically. There's this plethora of data that was available, and USGS and NASA deserve so much credit, I think, for that. And they inspired other agencies around the world to adopt eventually, similar licenses for their data sets. Interesting. Before I came to Google, I was in academia as a soft money researcher. And was leading something, I shouldn't say leading, I was participating in something called America View. Like in the United States, there's 50 states and about 30 to 40 of them have these state view programs. And they tend to be very applied. It's just like practical applications of remote sensing, usually coarse resolution, Landsat data. How do you make it more accessible to folks that aren't actually necessarily doing research on it, but just make it more useful for community college members, state governments, et cetera. They do incredible work with very small budget. And that's, I became the lead for Michigan View at the time. And one of the things, our activities, the barrier at the time was getting access to Landsat data, because it was free in terms of the license. Like once you had it, you can do whatever you want with it, but it was not free in terms of a distribution cost. It was about $600. And so a researcher would, buy that, or somebody would buy it. And then we're like, okay, now we got to put it somewhere where everybody can get access to it. So one of our major activities was like setting up these FTP servers. And anytime somebody bought a scene, we were a repository for it, that you could put it there. And, we got up hundreds and hundreds of scenes worth tens of thousands of dollars. But then Landsat opened their archive and just like, okay, that barrier is gone.
Right.
What else do we move on to? And it's great. And I'm so psyched when something I worked on all of a sudden becomes irrelevant.
Because, but I think it's for the it becomes irrelevant, but because that problem is now solved.
Yeah, there's plenty more problems.
yeah, for sure. And so let's continue down that story. Like the Landsat archive opens up and Google picks that up. What happens from there? Like, do people start using it, and if so, who are those people? Because there's those scientists that you mentioned earlier mentioned they were interested in that. There's usually a something that needs to happen between the moment someone says they're interested in something and they start using it. And so what made people come to Google Earth Engine and to start using it?
Yeah, it definitely wasn't an instantaneous thing. Yeah. And I have to admit here is like, at this point, I was not at Google. I was on the outside watching this thing happen. But the way, when I first started using it as outside of Google, I was still a researcher in Michigan with that Michigan View connection that I mentioned. And it was, at the time, it was a open source Java program that the idea was that you would, download this batch of Java data or code and use it to construct an algorithm that could work on, Landsat data. And I'm not a Java programmer, still not. Not many people in earth sciences are Java programmers, I would say. So that wasn't the most approachable. So there were certain communities that could make use of it. And there was a lot of work that was just going on by the Google engineers at that time, is working with the scientists. What are you trying to do? Okay, we will code that up. Not particularly scalable. One thing at Google is like, you're always thinking about, okay, you do this once, now you got to be able to scale it to more people or it just won't survive. So one of the major early changes was, and this probably is around 2001, yes, is that there was a JavaScript and Python API added. And that was right about the time I joined. And one of the first things I did as a developer advocate said, hey, I'm a Python programmer. I understand that community. I was participating in OSGeo, the Open Source Geospatial Consortium. And for a while, I was participating in their academic tracks at their annual FOSS4G conference. It moves around the world, gathers people together, and they usually, I don't know if they still do this, but there's an academic track of using OSGeo products for publishing research, and I did that for a while. Where was I going with that? But like
how Python and JavaScript you were mentioning.
So I was familiar with Python, that community. So one of the first things I did is like, okay, let's package this up. We're going to put this on PyPy. Later on, a few years later, Conda and CondaForge grew up. It's like, okay, we're going to package it up, put it there. So the folks that come from that community will have an easy way starting to use Earth Engine. It's definitely, if you look at our documentation, it is not the way we teach it. You have to come in with a lot of knowledge, basically, of Python and actually the ability to look at some of the source code to probably make really good use of it. But it's there. It's been there now for 10 years, that avenue for it. At the same time, there was something called the Code Editor Playground that was released, and that is still the main way that people get familiar with Earth Engine. Because it breaks down a lot of the barriers of just getting started. As long as you get whitelisted, then you can log in, and within 10 seconds you're actually like writing code against. So it's really great for workshops. It's great for teaching.
That's the lets you get whitelisted, you get access to that, and you have a console in your browser where you can start writing
Mhm.
JavaScript that lets you
Yep.
start querying all the data that's on Google Earth Engine.
Yep.
Right.
So that's sort of the easy path. If you just want to try it out, and a lot of our documentation will have links that will open up code within the code editor.
Right. Yeah.
And you can instantly visualize stuff around the world, which is quite valuable. It's built. There's many layers, I would say, of Earth Engine, or Swiss Army knife, is sometimes people describe it as. The code editor is a GUI application that handles things like displaying a map down there, a console so you can print output, prints charts. It has documentation built in there. There's drawing tools if you want to indicate geometry. So there's a lot of stuff it does for you. You don't have to set up yourself, but it's built on top of a client library for JavaScript. So if you're a Node.js developer, you can have access to the same thing. You just got to build it yourself. And then same with Python. We have Python client libraries that allow you to do that. Under the hood, Earth Engine knows nothing about JavaScript or Python. It is it's kind of interesting. There's a REST API, and you send a serialized description of what you want done to your data sets.
Okay.
And those descriptions can be massive. And then it will return something that you requested, whether it's a map tile, a table, a scalar, many different outputs. But yeah, it doesn't know anything about the client languages. And that's actually been beneficial for some users, is that they don't use Python or JavaScript as their main language, but they're pretty thin client libraries. So there have been folks that use Earth Engine that just write their own because they're working in some other language.
Right. So that REST API is accessible as well to anybody, right?
Yeah.
Okay.
Yeah. We don't recommend that you use it
imagine.
because that will tend to change more often than the client libraries. The client libraries are sort of like shielding you from changes in the system.
I have the impression, and please correct me if I'm wrong, but when I first discovered Google Earth Engine, I had the impression that JavaScript was the language that was pushed more than Python, and Python felt a little bit like a second-class citizen. At least that was my impression. First of all, is that the case? And if so, I thought it was kind of interesting because, at least from my experience, it felt like a lot of people who were doing the large remote sensing projects were using Python mostly for the scientific computing. So I was kind of a little bit curious as to why that was the case, if that actually is the case.
I think that the code editor was a big driver of that, the GUI environment. It was easier to sandbox JavaScript. Yeah. And that especially was the case back when the code editor was created. Because think of that, came out, 2011, 2012, somewhere around there. Yeah, and there wasn't the equivalent sandboxing of Python, and I argue sometimes there still isn't. It still isn't quite as easy to do that for Python. So it always has been the easier way to get started because of that code editor. And being somebody that comes from the Python community, I would agree with that. It's like we've spent more time with the JavaScript because that's the easier way to teach currently. In recent years, we've been more of a push to bring somewhat parity, that you'll start seeing more Python examples, tabs that you can switch back and forth. But there still is a bit of setup. I always think of that with any of these tools, there is a trade-off between ease of use and flexibility, that if you make something that's super flexible, it's kind of hard sometimes to solve the really easy use cases itself. And so it's always a trick. You make it, you add more buttons to your text editor, it gets more confusing to get started, especially if you don't use it every day. So there's a beauty in simplicity, I guess.
Yeah, no, absolutely. I that's also something actually I want to come back to later for the data itself. But before that, I've actually also been quite curious, as JavaScript is kind of the language of the internet. And I'm curious, have you seen people who don't come from necessarily the remote sensing or the scientific computation world, but more from web development or this whole aspect of building the internet that really relies on JavaScript a lot, actually jump on Google Earth Engine because it was written in a language that they might be more familiar with? or has that not really happened that much?
I wouldn't say that's probably hasn't happened that much,
Okay.
unless they're a really curious person. Aside from, because if I think of web development, geospatial is a small part of it. In general. So yeah, there's definitely incredibly good web developers that are on some of the scientific research teams, and they get hired for that reason. But then there's usually somebody guiding them in terms of like the why, and it's not as simple of just we need somebody to display an image on a Slippy map or something like that. It's much more involved than
Yeah,
that,
of course.
quite often. So
yeah, no, I was asking because I think something I've realized a lot through my own experiences of knowing just a very limited number of languages is that I really tend to gravitate towards the ones that I already know. I think the same if, for spoken languages, it's like, oh, there's this tool that I can use that's written in this language that I know. And then there's this other one that might be better, but that's written in another language that I don't know. More time than not, it's not worth the effort to, as an individual, to learn that new language. That's why I've been very curious about that whole question of like having those two, and thinking about who starts picking up those tools depending on what programming language gets written. But I'm
yeah,
happy to see that Python gets a lot of love as well.
yeah, it's interesting. By number of users, the JavaScript submissions to Earth Engine are higher. There's more people that use JavaScript, but in terms of the actual number of queries, it's more equivalent because
Okay.
Python is really good at automation. So if you are trying to do something and automate it, well, I shouldn't say you can't do that with Node, but it's very easy to do
Yeah,
that
yeah, yeah.
in Python. And so you'll find anybody that gets I don't know, finds that they can't do something using the GUI, the code editor, they might switch over to doing it from the command line, which is actually built on top of our Python API, or using the Python API directly. And that used to be kicking off export tasks, canceling export tasks. There's all kinds of stuff that you might want to automate on a regular basis.
Yeah,
And
right.
Python is easier to do that. And many of the advanced users do use Python for that.
Oh, that's pretty interesting to know. I mean, I think it totally makes sense, but I think that's a really interesting number on there. I do want to move on to the data that's there and bounce off of what you just said a little bit earlier about like that flexibility that comes with, like, it's a trade-off between the choices that you make and the flexibility that you gain. One of the things that I think Google Earth Engine does in a very interesting way is that a lot of the data is pre-processed in a way where it makes it very easy for different data sets to work together. I think that's like one of the hardest problems that there is in remote sensing is taking very different data sets and making them all work together. And I'll take an example that's quite close to the things I've been used to working with, which is the SAR imagery that's on Google Earth Engine is quite heavily processed compared to what any vendor might usually sell. And I'd be curious to ask, what was the reasoning behind that? Because you do lose a little bit of that flexibility. Like it feels like Google Earth Engine is quite opinionated on its data, to use maybe a term that comes up quite a lot in computer science. And I find that really interesting. And so I'd like to ask why that is the case and kind of what the reasoning is behind that.
Yeah. Opinionated.
I don't know if you think that's not the best word. Like that's just the word that comes to my mind usually when talking about things where it's a decision has been made in a
Yeah.
specific way, and it makes things simpler for a lot of applications. But you do lose a little bit of that flexibility.
Yeah. I mean, I agree with you. I was just mulling on that word, and that actually brings to mind ARD.
Yeah, exactly.
That as a topic. It's just like who's Joe that you had on recently?
Yeah.
I think you got into like ARD, and what he said is not controversial at all, at least in my mind. It's just like, I totally agree with him. It's like, I have lots of opinions, I guess, on ARD, and I've participated in those workshops where they're developing the standards for ARD and stuff.
So analysis ready data, by the way, just to explain.
Analysis ready data. I guess one way that I think about it is that the groups that distribute data like USGS, NASA, they have long had multiple levels of products. A level 0, usually it's in the sensor geometry. It's probably not in any regular grid, depending on what type of sensor it is. And then you have level 1 where you start, and the level definitions vary from, I think, provider to provider, but in generally, it gets easier to work with as you move up. And I think that by the time you get to level 4 of like NASA, it's like a physical product. It's like a physical measurement that you conceivably could go out in the field and measure and compare directly. So in my mind, for some people that's doing a certain type of analysis, that is analysis ready data. They've been doing this for a long period of time. But as you just pointed out, is like, as you put on those processing steps, you're narrowing the flexibility of like what somebody can do with the data. When I was doing my work at, it was a nonprofit and then became part of an academic group before coming to Google, is like I worked with level 0 data quite often because that has the strongest signal if you're really looking at extracting all the data or information that you can out of data. And the fact that it is irregular is a benefit. I mean, my PhD is in geostatistics, so it's like the more variability that you have, usually the better. If you can have data that's coming in at different resolutions, not always from the same view angle, the spectral characteristics are different, it's harder to analyze, but there is more information that you can extract from it. I like to think of like a lot of remote sensing that I deal with and the partners I do is not looking for objects, but it's looking for characterizing phenomena across space and time. And remote sensing is basically just snapshot observations of it that have in its little small windows. Like you're not seeing the full spectrum, you're not seeing it at all times, you're not seeing it at perfect spatial resolution. It's basically you're sampling it. And if you can recognize that and take advantage of it, your estimation of a continuous model in space and time will be much better than if you had a single uniform data set that's been pre-processed.
So how do you decide where you put that slider? Because as you said, there's like, I mean, I view it as a slider, let's say between that level 0, which I think might be, for example, a point cloud for LiDAR data. And then all the way to that level 4. I mean, again, those numbers kind of vary, but that's the measurements. For something like Google Earth Engine, the slider has been put somewhere specifically. And so I wonder how that decision has been made, or, it's probably even changed over time. I actually don't have that much experience with it just over the past few years, but I'm quite curious to know how that decision goes on to be made.
Yeah, usually we're kind of reaching out to the communities that are most involved in a particular sensor and asking for their advice on it. In some cases, we will have multiple level products.
Okay.
It's great if they've standardized around something that we can just say, hey, we're going to put a copy of this up there. Earth Engine, its data archive is a mirror, I would say, rather than an archive. We never want to be the original source that you go to for things. We are a copy of very useful data. So example for Landsat, there'll be a Landsat collection 1 TOA, raw scenes or TOA. There might be a collection called that. That is something that USGS produces. In some cases, they gave us a software to run the same process to produce it, but it's supposed to be a exact mirror. When you get to something like SAR, then we are using the community's description of how do you run SNAP or some type of SAR processing, and it has evolved over time. It's like we will put out one there, put out a data set, process lots of scenes to it, and then say, okay, work with this for a while, tell us what you do like or don't like about it. It's a sort of an iterative process to come upon a processing chain that you really like. And most of the time, we're not that opinionated ourselves, but we have folks that we work with in the community that are opinionated about this. And not everybody's going to be happy with the choices that are made, but our job is to make them at least clear, make it clear which choices the data did follow. I didn't say that very well, but
No. I see what you mean. And we've
yeah.
actually been talking about the community, and you mentioned earlier that's a lot of the job that you're doing today is talking with these people and understanding what those needs are. I'm actually quite curious, like, who is the Google Earth Engine community? What is it constituted mostly of? Is it a lot of people in academia? Is it like a lot of students? Or is it just very diverse and there's not really one category? It's just like very, very different, broad amount of people.
I think it comes from the history of Earth outreach and just the early goals of Earth Engine is that we have worked with partners, like experts in the scientific or nonprofit communities, that they have a really good idea of what barriers exist and what needs to be done. And we're trying to build something to solve it for their use cases. And the best thing that somebody who wants us to change Earth Engine can do is describe their use case in something that matches of solving an environmental or social issue. Because that's our community that we have worked the closest with. That tends to be some academics, but some academics are interested more in just publishing a paper and moving on. And while that can be an interesting milestone, it's not really going to have impact directly on social and environmental issues. So it's more folks that are working on applied science, making the scientific community advance faster so that we could address a social and environmental issue. And then there are nonprofits that we work with that will pick up the end results of that research and use it in terms of their outreach, trying to build awareness of a problem, how change is happening in the world. And sometimes what we're getting to now, which I'm pretty excited about, is other people that have a lever to make change in the world. So getting Earth Engine into their hands. So it's not, and sometimes it's not a super broad, well, how do I say this? When I go to the ARD and Stack meetings, there were folks that were coming and dealing with satellite data, but they have more of a business mindset, building a startup or something like that. And they're like, we don't understand Earth Engine. Why are you doing this? And that's totally fair, because that is not the community that we were building it for. We were building it for folks that were more focused on sustainability issues. And they, as I said, they tend to be in the nonprofit philanthropic world, some in academia. But I'm excited to see that. I mean, that's not always the case. There are companies, and they're starting to get a lot more interested in it. And I was really heartened to hear a lot of the interviews that you've had is like they mentioned why they came to geospatial is because of some goal of working on climate change or some type of sustainability related issue. And so I think it is somewhat widespread. I guess what I'd like to say is that I'm happy that we're able to expand out access farther, because the community is broader than the one that we have been serving up to this 10 years and have been guiding our development.
On that note, like, one of the things I got really excited about is that Google Earth Engine just very recently, at the moment we're recording this, announced that there's going to be commercial partnerships that are going to be done. And I was very excited that this happened just before our interview, because this is something I've been thinking about. And a lot of people have raised that aspect of like not really knowing where Google Earth Engine was going, and especially on the commercial side of things, not being very sure about whether it was worth going towards or not. And so this sounds like the fact that Google Earth Engine is seeming to be open to commercial partnerships, at least to me, made a lot of sense. And so I'm just curious as to what the current situation is right now. I think it's still a very early step towards that. I just wanted to ask a little bit what that looks like. Are there already people that you're working with on that, and what do those partnerships look like? I'm just wondering if people are listening right now and they're wondering about, they have this idea of making something. It's it's not very appealing right now to think that you're going to have to figure out everything on your own. There's Google Earth Engine, there's Microsoft Planetary Computers. All these things are starting to pop up. But from a commercial point of view, I'm very interested in knowing, what do those partnerships look like, or what are they going to look like?
Sure. I guess I would say that this was a pretty significant milestone, at least a public announcement about it, but it was something that has been going on for a while.
Okay.
We announced some of the partnerships, and if you go to Earth Engine's commercial page, you'll see listed in there that we've been working with for a while. And because there always was a way to use it commercially, but it was not a formal program. It's like there was researchers that were working with Earth Engine, and then they found it valuable enough that they wanted to have it part of their operations. And the USDA Forest Service is a really good example of that. Is like they both play in the research publishing world, but they're also, they do operational monitoring of their lands. And I think that there's quite a few groups that play, or agencies, government agencies that play in both those worlds. And then the other thing that was going on is that people would be using Earth Engine when they were in their college education, and they go off to get jobs in companies around the world. And they're like, hey, we've experienced this. We got to get access to this. There's so much we could do in this new role. So recognizing that is occurring, want to give a way for those companies that have already the capacity to use Earth Engine, a way to do so. And so it is a private preview at this point, so it's limited, not wide open, and that will change. Pricing has not been announced. That will be determined too in terms of working with these partners. But it's good, I think, having a public statement about what's been going on for a while, I would say.
Yeah.
And I'm very excited about it because, as I said earlier, is like, these groups, if you're in a government or in a multinational corporation or even like startups too, is like they may be some of the largest levers of impacting real change, depending on what they come up with, because they affect a lot of the natural resources, either the governments that are managing domestically or the multinationals that have supply chains spreading around the world. What they do has a big impact on everyone. So helping them make good decisions is totally aligned with our goals, and I'm very excited about that.
I think it's also probably very different levers from the NGOs that you might be working with. If you start working directly with big multinationals or governments or startups, I'm guessing that also broadens the horizon of, as you said, levers that you can pull that can create change down the line.
Mm-hmm. Yep. And we recognize that they will be different to work with. And
I can imagine.
I mean, one of the great things about the announcement, as well as just the use of Earth Engine to date, the folks that have been using it in a free manner, the nonprofits, academic stuff like that, we're very clear that is unchanged.
Right.
It's just we're inviting some additional people to the party, I guess.
Right. I guess so. We're still a bit too early. We're going to have to chat again later when things open up a bit more. Yep. One of the things I'm curious as well is there a way where a lot of the times when you start working on a problem that has a geospatial component, you're not quite sure what the data that you're going to need to use is. And so one of the things I've been quite curious is, is there a way where you can also bring in kind of your own data to Google Earth Engine, or take what comes out of that and try to mix and match all of that as well? Because there is this, you might know you need Landsat data, for example, but maybe you want to validate that with some ground sensors that you have that aren't currently part of Google Earth Engine. and I just haven't explored that part actually that much. But I'm curious as to is that process possible, and is that actually something that happens quite often if it is?
I would say, yeah. I mean, for any elaborate analysis, you're going to want to be bringing in your
Yeah.
own specialized data. So yes, there's multiple ways to get it in. At the REST level, there's a way to ingest a raster or vector data set in. Our client libraries support that as well. If you get into the code editor, there's some task panes that allow you to kick off a import geotiff or import shapefile or CSV job, and it will appear. And it's nice that it's part of, from a technology perspective, it looks the same as the public data, but it is ACLed, or the access control is private to you, whoever uploaded it. And you can, similar to Google Docs, you can choose to share it with other individuals or groups, or make it publicly accessible to anybody that has opened it up. So that works, but it works for smaller data sets. The reason that we have Landsat in there, the full archive, is that we've been ingesting it for years. I mean, so there's so much data that there's only so much data that you can bring in by that method. And we do give 250 megs of default storage for anybody that signs up, that you can fill up with your own data. The other way to get data into Earth Engine, for raster data at least, is that you can put cloud optimized geotiffs on cloud storage and then just refer to them. So in that way, you don't have to go through the ingestion process. There's a bit of a performance penalty because we've optimized the raster reading for native Earth Engine data, as opposed to what can be read from cloud storage. But depending on what you're trying to do, that might be a totally viable option. If it is training data, then you're probably easier just to bring it in, because it won't usually be that massive. So that's getting data in, and then the other way around is fine as well too. You can pretty much export any object that you've created in Earth Engine, but you just have to define, at what resolution, what projection, where is the destination. If it's a small amount of data, you can download it through your browser. If it's larger, you might put it in Google Drive. If it's really massive, then you're probably going to be using cloud storage if you're exporting a continent or something like that. So yeah, it is possible. There are, when you're moving that much data, regardless of what is generating it, it can take a while. So we try to use the tools that are built for managing the appropriate amount of data.
I can imagine also a lot of those tools have changed over the time that you've been at Google working there. I can imagine a lot of these things have changed as well. And I'm actually quite curious, do you think there's anything that you can already foresee over the next few years that might come to change on what Google Earth Engine looks like? I mean, that we can talk of as well. But like, do you think there's like any big major changes that might happen on a timescale of 5 years or something like that?
I guess those are hard to know at this point. And well, I know it's one of those things that, as I said, we go back to our community quite often and say, all right, what's your current barrier? And sometimes, yes, we can look out a little farther and see things that are coming down the pipe. Maybe it's a new satellite data type that is being launched that we know is going to be valuable, and we could plan for that. There is so much potential for, I guess many people call it data fusion, but I just think of it as observations of a phenomena with different sensors. To me, it's like taking advantage of the fact that there are all these different modalities of data collection. And that, I think, is something that Earth Engine can do quite well, but it's been underutilized. As you mentioned before, you said it was easy to combine data sets together, and what we were able to do is store it in its native projection resolution bit depth, and then do a reprojection on the fly with pretty much anything, which allows that choosing the appropriate output is easier if you have access to a low-level product. Back to our discussion of ARD is like we try to keep the reprojection advances and even the cloud masking to be options that the users can select and apply on the fly, as opposed to pre-baking that
Right.
in.
So if I understand correctly, you're saying that the approach you're trying to take is rather than having those stored pre-processed products, rather have the ability to rerun them on the fly, depending on whatever is required and
Yeah.
is needed.
And it is a trade-off. I mean, some things
Yeah.
take too long to run on the fly, and it's not worth it. If I go back to an earlier example, I spent a good period of time coding up the fmask cloud masking algorithm for Landsat scenes in Earth Engine. And it was pretty flexible. You could choose your thresholds that you wanted to mask out. But then USGS a few years later introduced a quality band that basically ran fmask, or a version of it, they call CFmask, for 3 different thresholds, I think.
Right. Okay.
And at that point, we're like, okay, it wasn't worth the flexibility that we had made available, and the speed that it ran in Earth Engine wasn't worth maintaining anymore. So we were like, we'll take that out. We'll simplify our system, because now we can go back to.
Yeah. I think that's actually a very interesting trade-off, because I think a lot of the things that I hear a lot of the time is that storage is cheaper than compute, and so you wouldn't want to be able to rerun those all the time. You'd want to do it once and then be able to store it. But I also guess that if Google is taking a crack at that, that's probably different economics that regulate how that happens.
It is a trade-off, and that comes into our design of like, what do we cache to reuse rather than recomputing, and cache causes, it takes storage too, so it's always a trade-off of what do we cache and how long does it stay around. I think the biggest driver is bandwidth in most of these calculations. It's just like you have to figure out how to transfer as little data as possible
to the end user.
To the end user.
Okay, right, yeah.
I mean, so you want to do the analysis early on, so you can transfer really small things. Sometimes they're just like JPEGs, PNGs, to make, especially if you're building like a application that is reactive to a user's inputs. And some user inputs you could fold into an algorithm and still get back quick results. Other ones, you probably will make it'll take too long, and the user will get bored with it. So it's always a little bit of a trade-off.
Yeah.
But the bandwidth thing is interesting.
That's a really good point. I think I maybe very naively never had thought about that, but that's also a consideration that has to come up, is like, because you're displaying the results of those analysis directly on the user's browser, rather than something where a developer is running on a local machine, or they're SSH'd into a remote machine, and that bandwidth doesn't really matter. Here it really is something that is that extra layer has been added, and I guess I just never really thought about it, but I can imagine that's something that really comes into consideration as well. I think I could geek out for hours on like exactly all the implementations that have been done for Google Earth Engine, but I do want to move on a little bit. There's one project that I think you worked on that I wanted to talk a little bit about, which is called OpenET. I think is the name of it, and so that's about water use. And so I think you can describe that better than I can, and I'd just like to know if you could describe a little bit what that project is, and we can go on from there.
Sure. So the project is called OpenET. ET in this case is not the extraterrestrial, it is evapotranspiration. So the easiest way to describe that is water transfer from the Earth into the atmosphere by 2 different methods. One is evaporation. So if you have water coming off of soil or open water, like a reservoir, it goes from liquid to gas into the atmosphere, and that's evaporation. And if a plant is involved, that is pulling it up through its root system and releasing it through the process, of growing, that's transpiration. And so it is a very important process because there is so much agricultural production that goes on throughout the world. And in many parts of the world, they're water limited. And so making efficient use of water for agriculture is something that is very important to folks that either use or manage water. It's a very hard thing to measure, even if you go out in the field. Like, think of if you go into a field of corn or wheat or whatever, how do you figure out how much water is actually going up there? You can install really detailed meteorological towers that will measure fluxes in terms of which way is the wind blowing, what is the humidity near the ground, and how does that change as you go up in height. But those tend to be point measurements that are really hard to maintain, or they require somebody to maintain them. It's not like a thermometer. So it's getting ground data is really tough, and part of the OpenET project is looking at all the places where ground measurements were taken and cleaning them up so that the scientific community that is trying to estimate evapotranspiration from remote sensing has a really good ground reference data. And I hate the word ground truth, because you got to realize that anytime there's measurements out there, they have errors in them. But that's kudos to OpenET and the funders of OpenET for identifying that is such a key component. And as a little tangent, I mean, I think that is one of the biggest things that people have to focus on for remote sensing is like, what is the quality of the reference data that you are comparing your estimates to, and where did that come from? When I was a grad student, I was skiing around in the watershed of Colorado trying to fix electronics in winter that measured snowmelt. And if you think that data was perfectly accurate, I mean, you haven't spent much time out in the field. And even the other data that I was measuring quite often was snow depth. And you get an army of people with these long poles, and they are probing the ground, trying to figure out how much snow is there at the snow depth, to figure out how much water content there is. But if you put somebody like that on skis and you ask them to go up a valley, they're going to avoid rocks, because it's unpleasant to either walk over rocks with your skis or for other reasons. So you get biased sampling. And I think that goes for almost any case that you have ground reference data. There is some type of, it's very rare that you don't have some type of issues with the collection of data. So validation of remotely sensed data is kind of a tricky topic. And I kind of, when I see that in papers, when they say, it's been validated, I'm like, well, I don't know if that means what you think it means. Anyway, that's a tangent. I'm saying that OpenET is doing a great job in a really difficult situation for that. The other thing that's really interesting about OpenET is that the science of estimating evapotranspiration from water has been ongoing for the last couple of decades. There are groups around the world, research groups in academia or government research labs that have developed these models. They are usually based on some simplification of an energy balance model, which means that if you figure out what the temperature change is, and you know that energy used for that temperature change is the transformation of water from liquid to vapor, you can get an estimate of how much water is going on. But there's all kinds of confounding things that are going on at the same time. So that's why these algorithms tend to be somewhat tricky, and they have different simplifications. They don't all yield the same results. But that field had been evolving, as I said, for the last 2 decades, and it was really hard to compare results because they're all written in different systems. Somebody might need IDL or C or Python or something like that. And so it's very rare that more than one of them was run on the same set of data. And as with most things in the natural world, the variability is huge when you go from site to site. So one thing that OpenET was able to do is get 6 of these ET models from some of the leading researchers, all ported into the same system so they can work on the same inputs. Often it's Landsat data because it has a thermal sensor, but other land cover data sets, meteorological data sets are important for these models. They could run them all in the same place. So you sort of could come up with an ensemble of results, and models are known to perform better in whatever area they were developed for. So some of them do better over forest, some of them estimate, reservoir evaporation better than others. But it was really easy for these modeling teams to compare. And so one thing that actually slowed down, I would say, the release of OpenET is that once they saw how their model was comparing, they immediately saw areas that they could probably fix. And it became this collaborative feedback.
Right.
They're no longer competing for funding, because we had the funding part solved for a while. It came from philanthropic organizations. And so it sped up science, I would say. It's just like they had these rapid iterations of releases of their models, and they would just want to run it again over all the areas where they had ground reference data. And that's happened a few times. And at some point you have to say, okay, you got as far as you can for now. We have to release the product. We'll come back and do, improvements in the future as well. But for me, that was totally exciting. It was like using a carrot, I guess. It's philanthropic funding from a different source that had different rules than the normal set of funding that allowed these folks to collaborate together and move the needle further. They also did a really good job, and credits to EDF, the Environmental Defense Fund, who is doing project management for OpenET, of identifying a diverse set of use cases from conservation groups, agricultural collectives, water irrigation districts, state agencies, trying to figure out what they really need, so that we're not just designing the shiniest data generating platform, but make it actually simplified enough so it's actually going to be used. So serving both the scientific community, moving the state of the science of estimation of evaporation forward, but then also really getting practical results. And the website that was announced just a few weeks ago is pretty spectacular. I mean, you get to go look throughout the Western US, where water is definitely an issue, water usage. And you can either look at the broad scale raster view of each month, how much evapotranspiration is estimated from these 6 different models, or you can look at it aggregated into individual agricultural fields and look at that history, and just making that open. It's OpenET. The idea is to make it as openly accessible to everyone, so that everybody has a level playing field of where they're starting. The best available science, that you can start now having a discussion with a rigorous, peer-reviewed scientific backdrop of something that's really hard to measure.
So I actually want to ask about finding those use cases, but because as someone who has, I also consider myself an engineer, and I understand the technical problems, and I understand how you solve some of those, but how you put that in the hands of someone and that they go like, this is actually useful for what I'm trying to solve, is an entirely different problem, and one where there isn't any documentation, or it's very different. And so I'm quite curious to ask, what was the process like for that? Because one of the things I was very surprised and pleasantly surprised on, and looking at the OpenET website, is that the use case category looks massive. It's not just one use case. It looks like there are multiple ones, and it feels like, this is something that is solving many different problems and isn't looking for solutions, but rather brings in a lot of value. At least that's the feeling I had from looking at the website. And so I'd be quite curious to ask, what was that process like, and how was that process baked into also building that solution in the first place?
Yeah, I guess the process was, I will say this in terms of a statistician. It's like there's a lot of unknowns out there, and you don't know what the right process is to start off with, but you have some evidence based on past successes of what you should do. And for me, that is going to events where there's people that have knowledge that I don't, that at least I have enough to be able to take part in the conversation, but I don't know what the solution is. So we're looking at the outside world for guiding what we should do. And in this case, it was being invited to go to I guess you'd call it a think tank meeting at Aspen, where they get a bunch of academics, government folks together, philanthropies, and it was around, I don't know, 30, 40 people. It's called the Aspen Water Institute. I might have that name wrong, but that was about 6 years ago. And you fly in there and give a little presentation. I showed them what was going on with Earth Engine, and then you listen to like everybody else give their presentation on what they're working on. But then it's a meeting where it's off the record in terms of nobody reports out what is being decided. Like you don't attribute it to any particular person, but it allows for a lot of free flowing conversation. So it attracts people that have strong opinionated ideas. And I got totally intrigued by like some of the participants there that were from philanthropies. And that is a group that I hadn't worked with much before. And so, hey, as I said, this is sort of my skills. Like I find somebody that I'm curious about, I'm going to go find them at meetings. In here, it was kind of easy because there's only like 30 of them. And just so started talking with two folks. One of them was from the SD Bechtel Jr. Foundation. And another one was from something that was called a Water Funders Initiative. And the Water Funders Initiative was a collection of philanthropies that cared about water issues. So they totally knew what the use cases were, but they didn't know how to address them all and have large scale impact. And so there was a sense that maybe something was there. So we invited them to come to Google and tell us more about what they thought the issues were within the areas of the Western United States where they were focusing on, and they did that. And we, once again, told them a little bit more about what technology potentially could help with. And then we figure out that there's not the correct people in the room. So you start inviting the people that are at the intersection of that in research to come and do a meeting. I think we did it at NASA Ames. We convened about 50 folks that work in the area of doing research in this area and said, hey, you're going to educate a bunch of philanthropists that have money, show what's possible here. And so we mediated that. It seemed to have enough traction that there was interest from the philanthropies in funding this type of idea. So they gave some seed money to the Environmental Defense Fund to organize a project. And they came up with, organize the use cases. As you've seen, they did a great job of that, figured out who were the key folks that they wanted to invite. And it's changed a little bit over time. What we originally set out to do didn't quite come to fruition in terms of all of the people that were there, but they got it right, I think, in a large part of like they said, hey, we're going to spend a lot of time on doing networking with these end users. I mean, that's a huge part of the budget. And they had annual meetings, trying to get constant feedback along the way. Like, this is what we're working on. Does it seem to be going in the right direction? They got a fabulous team to build the website, a group called Habitat 7 that had done a lot of sustainability related geospatial websites before, like in terms of US climate data. They have lots of great stuff there. And I guess at that point, it looked like a viable enough project that other philanthropies wanted to chip in money, and then EDF could be the one that is actually doing project management to organize these 6 different research groups. And then it was a process of many years of actually gathering all that ground reference data, porting the models to Earth Engine, getting them to run, doing the revisions because they wanted to improve them. So it's been great. I mean, they are strong users of Earth Engine. I'm very proud that we built a lot of capacity that is outside of Google to do this type of work, and that involves back to what I was saying, that the importance of version controls. Like, they're all over it now. They see the value after working for years and trying to coordinate multiple models that are running on the same data. That's the only way they can manage that type of complexity. And in some sense, it's just sort of just getting started in some ways. Like, this is the initial release. They have plans for rolling out an API in the spring that will allow much more fine control over the data that is being collected, and allow it to integrate it in other software that needs this water use input.
I want to come back to one of the things you said at the very beginning, or around the beginning of this conversation, which is telling stories. This is one of the things that I'm slowly starting to really discover, like the power of just telling a story. And I really wonder, do you think the work that you've done, for example, at OpenET, can that also be used to tell stories about things like water management? Do you think there is room for that as well, to do some of that education, to do some of that outreach back to what is possible with that? I mean, just what you were saying earlier about those researchers that talk to philanthropists, I bet that's putting on a story, like telling that story about what you can do, and making that connection with people. That, we love numbers, we love statistics, we love tech and everything, but I think that doesn't connect with everybody, but stories really do. And so I'm really curious in that context. Have you seen it being used, also, or do you see it being used to tell a story about, leveraging that data, but for the sake of storytelling, to make that more accessible to people who might not get super excited like us about this great platform?
Yeah, I guess if you're referring to the stories of OpenET, that is sometimes a little bit tricky, like similar to geospatial in terms of being a niche. Water is one of these things, is like everybody uses it, but they don't think about it all that much. So it gets certain people excited, and the stories of how this data transparency might excite them. So, and I think EDF has done a pretty good job of doing that in a careful manner. Another thing I would say, it particularly applies to water, but also many other natural resources, I think, are the same way, is that transparency of this information is threatening to some folks. And you have to be mindful of that when you're doing your outreach and storytelling. It is transparency, in my mind, is generally a very good thing, but you got to be mindful of that. There are players that it changes the status quo, and that's not going to make everybody happy. I think it's easier to talk about that in terms of deforestation, like monitoring. That the transparency, I think, can always bring positive change, because you see where it's going on, and then somebody will have to explain themselves if you're doing it at a very large scale. And I would say that some of the early work that we did with Earth Engine and supporting groups that were trying to get out information and tell a story about deforestation in Brazil were successful, in terms of, Brazil used to report numbers in terms of deforestation, but no GIS-like products. So it was sort of a little bit of, trust me, this is the number that we're reporting, it's the official number. But when a group would say, okay, so where is that deforestation?
Yeah.
What are you counting it as, and what are you not counting it as? That wasn't happening, but with the transparency that Earth Engine brought, these watchdog groups could produce their own maps and say, hey, this does not jive with what you're actually reporting at the national level. And then Brazil started reporting, spatially explicit information around with it. So then it helped that conversation around. I wouldn't say that there's so many confounding factors that I wouldn't say that's necessarily solved it. I mean, Brazil is still deforesting. There's so many other things, political, cultural. And I guess one part about that, as a little bit of a tangent, I realize that I and many in our industry are just in a place where it's easy to say, hey, this should be done, because we are comfortable in a sense. It's like we're not affected day to day, trying to survive in a way that many communities around the world that are using natural resources are. So you also have to be compassionate about when you're trying to bring change, it impacts folks. Even if there is true environmental degradation going on, there's many, if you stop that, there's other impacts that might be equally as important that might come from
Absolutely. I
trying to
think
stop.
this is one of the things I'm learning, and I want to learn more through those conversations. The conversations like this is talking to people who actually have done it and realize, well, making the platform was just half the work. Then it's having that compassion. Sorry?
To me, it's not even half.
Yeah,
I mean,
or not even half.
Yeah. If you think of it as now producing national scale outputs to the geospatial, it's not that novel a thing anymore.
Yeah,
it's
true.
it can be done, but actually producing something that is meaningful, that people can actually make a decision on, that they trust the quality of, that work of usually it's, generating a global scale product is now on the order of days to, a week or something like that for many different companies. But the work that is proving that it is useful, like doing the scientific validation against ground reference data, that can take years.
Yeah.
And then once you have that, there's many folks around the world that don't care. I mean, they're going to act in the same way. It's just because we've generated this knowledge. We still have a lot of work of doing the communication to raise the awareness of everybody who's impacted, and then getting it into the hands of decision makers. So I guess if I move away, I guess, from staying on storytelling, but moving away from OpenET, is like one of the great things that Earth Outreach has done is just helping people, environmental causes, tell their stories on things like Google Earth so that people have a frame of reference to it. There's work that's done on landmine removal. There is great work that the Jane Goodall Foundation has done in terms of biodiversity tracking, how that has changed in Tanzania and other areas. Malaria mapping. You just think of all these things where you're just bringing more awareness. It's not just like a number that you read or a little image. It's something that you can sort of more interact with. And there's a great part of Google Earth where there are really highly curated stories that will allow you to explore people's homes around the world, or indigenous communities, which I think is great. So that, to me, that's more of the storytelling platform. Earth Engine is something that can generate data that you might want to tell a story about, but there are much richer, I guess, storytelling platforms that are available.
Yeah, I'm I think a big believer in us trying to, us as in this whole field of geospatial, but just data in general, of leveraging that to connect to people. I think just the simple things, like when I talk to my mom about what I do, I don't tell her about, oh, I process like 10 terabytes of data. It's like, no, I tell the story of the problem we're trying to solve. And then, oh, it so happens that, as you were saying earlier, if we were to measure that with on the ground, it would take a lot of people, a lot of infrastructure, things like that. And so I can do that from my laptop to a certain degree, and that solves 80% of that specific problem. So I'm a big believer in that, and I think there's definitely value and a lot of room to keep telling those stories. I think that's how we connect with the people out there who just don't have any idea what this whole space and satellite thing is about. I think I this is actually a nice place to leave it there. Again, I finish these off always by asking the same thing, and you've listened to these, so you know what's coming. I'd like to ask if you have any book recommendations about anything, just geospatial or not, or movies or podcast, documentaries, series, and any media in general that you think has been inspiring, then that might be worth sharing.
Yeah. I think the one I'd start off with, because it touches on a lot of kind of my interests, is something that's called Bicycle Diaries, and it's by David Byrne, who is one of the founders of Talking Heads. But it is a book that is just his travels of the world, going to different places and bringing his folding bicycle most of the time, so he could like pedal around the cities. And it talks a lot about culture, music, politics. To me, that was totally interesting, and they're all like short little chapters. So that's one that I've really liked. When I do travel, and that's one of the things I've really missed out on from the pandemic. I don't get to go to the international science conferences, or haven't for a while. But when I go to these areas around the world, I love to get like a local history book. And
Okay.
sometimes, they're not necessarily even professional authors or something like that, but they did the work of like figuring out what stories have gone on, whether it's a century or 2 centuries, depending on like where you are in the world. I find those to be really interesting. I guess other things that I don't have a lot of time, I would say, to dive into books so much now, unless it's like reading to my kids. So it's a lot of
They're
shorter
great books for kids
things
as well that people come back to much later.
Yeah. No, I do enjoy that part, but the often are repeats of what I read earlier. I would say one thing that does entertain me, and this is actually a little bit coincidentally of like when we first had our conversation, is like bike packing. There is a
Yeah.
website called bikepacking.com, and it has, once again, these stories, not by professional authors, but they just tell you about little adventures around the world and what they explore. Because I love exploring things by bike. I think that's one thing that I agree with that David Byrne is like, that's one of the best ways to like explore a lot of area, because you can travel far, but still be kind of part of it. And that's the first time I ever came over to Europe was, I got off the plane in Frankfurt, I guess, and assembled my bike and pedaled out of there.
Right.
And then spent like, I don't know, 2 months pedaling around with a friend. So yeah, bikepacking.com, that's a little pitch for a really small niche community, but just with beautiful imagery and stories in there about exploring the world.
Yeah, I'll definitely put that. I'm like, we did start getting in contact when we were both bike packing. So I think, yeah, I can totally relate to that.
I think I was going to say another one that I've really been interested in, and this is not actually the content, but it's more the platform, is Jupyter Book. It is an open source project of using, the Jupyter technology, which we didn't talk about too much in this, but I think is highly influential. And it's a way that people are just like writing their own interactive books. I mean, with the ability to like get in there and run the code. And I find that like fascinating. So I haven't read many of the books in there, but I'm amazed at that technology. And another similar one that is Fast Pages, which is just
that's what I was thinking about.
Yeah. So it's a longer form version, I think, of Fast Pages in some ways. It kind of scratches the same itches. And then the final one I would mention to folks, and I mean, we talked a little bit about collaboration and how people get along and how we can influence that. There's a game designer, her name is Nicky Case, and she wrote something called The Evolution of Trust. And it's this little, I guess it's a game, I don't know, it's an educational something on the web that you play along with, and it brings you through some early game theory concepts. And it's about how communities that interact over time in multiple ways, like how should they behave and what actors have the most influence on the community. And it's fascinating. I mean, that's one of the things, I want to show my like little kid because he'll understand it. But it's like a high level concept too, as well as like all these people that are studying game theory.
Oh, I love this. Anyway. I don't ask about people if they have game recommendations, but I'm a big fan of those. I think from small games, like the one that you seem to be talking about, all the way up to really massively complicated AAA games. I think there's a lot of experience that can be communicated and transferred to that medium. And so I just love that recommendation as well. I'll be sure to check it out and put it in the show notes.
Yeah, I'm not actually even sure I'd really call it a game. She is a game designer.
Right.
I had read about it, but it's just it's information in a little bit of a try things out and push some buttons form rather than a full game. But yeah, I'm fascinated by how well of a communication vehicle it can be for somebody that is skilled in that way. Yeah.
Well, awesome. Tyler, thanks a lot. This was an amazing conversation. This was great. Thank you for spending some of your valuable time with me.
Well, thank you. I really enjoyed this, and I look forward to hearing more of your podcasts in the future. I'm really excited that you're doing these long form ones because I've learned so much from listening to your past speakers. Some I've met before, some I've just heard of before, but I learned something from listening to each one of them.
Thank you very much.